Hey, my friend, Arthur Morris here. Hope all is well. In this video, we're going to look at numerical integration. And numerical integration includes the trapezoidal rule and the Simpsons rule. So as you can see here from the textbook, it says that some elementary functions simply do not have antiderivatives that are elementary functions. For example, there are no elementary functions for these following functions here. But if we need to evaluate a definite integral involving a function whose antiderivative cannot be found, then while the fundamental theorem of calculus is still true, it cannot easily be applied. So in this case, it is easier to resort to an approximation technique. And two of the techniques that we're going to use are the trapezoidal rule and the Simpsons rule. Okay? So we're going to look at a couple of example problems here. And the first one we're going to look at, well, first of all, let's just look here. So looking at numerical integration and the formula that we're going to use, we're still looking for the length times width of of rectangles, sorry. So the first formula we're going to use is the trapezoidal rule. It says let f be continuous on a closed interval from a to b. The trapezoidal rule for approximating the integration of f of x dx from a to b is as follows. So integration of from a to b of f of x dx is approximately b minus a over 2n, and remember that goes back to what we looked at before, times f of x sub 0 plus 2f of x sub 1 plus 2f of x sub 2 plus and so on until we get to the n, and where we don't multiply that function by 2. Moreover, as n approaches infinity, the right hand side approaches f of x dx from a to b. So we're using that right endpoint rules here. So we'll use the trapezoidal rules. So make sure you pause the video and copy down this formula. Okay. Now to get a closer approximation, if the number of intervals is an even integer, we can use the Simpsons rule. And it still says from the integral of f of x dx from a to b is approximately b minus a over 3n times f of x sub 0 plus 4 f of x 1 plus 2 times f of x sub 2 plus 4. So above it's we don't have a constant multiplier in front of f of x sub 0, and then we have 2 2 2 2 until we get to the n. And Simpsons rule, we don't have a constant multiplier in front of f of x sub 0, then it goes 4 2 4 2 4 2 until we get to the, or yeah, 4 2 4 2 4 2 until we get to the end. Okay. All right. So what I want you to keep in mind is what we looked at before when we looked at our right hand rules for integrations. When we did this using the limit rule and Riemann sums, remember that x sub I is equal to a plus I delta x, and that's where that x sub 0 comes in. That's the x sub I, and then x sub 1 and so on. And then remember, to get that, we needed to know what delta x was, and delta x was found by b minus a over n. So the first thing that we want to do when we work these problems, so using the trapezoidal rule, hold on, let me make sure you can pause the video here and write down that Simpsons rule. Okay. All right. So the first thing that we want to do to find the integral of x squared dx from 0 to 2, where n, the number of intervals, equals 4, using the trapezoidal and Simpsons rule, we need to find delta x. So step one, you need to find delta x, because our goal is to get it back into this formula, b minus a over 2n times f of x sub 0 and so on, but we need x sub 0, x sub 1, x sub 2. So the first step to get there is delta x. Okay, so remember, a in this case is equal to 0, the lower bound, and b is equal to 2. And then it tells us that n equals 4. So we see that delta x equals 1/2. right? So the next thing we want to do is we need four intervals going from 0 to 2, so we need to find x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4. So x, and we're going to use that by using our x sub I here. So x sub I is equal to a plus I times delta x. Therefore, x sub 0, and we always start with 0, and we have four intervals, so we're going from 0 to 4. X sub 0 is equal to, and we know that a is 0. I in this case is whatever interval we're on. We're on interval 0. So 0 times delta x. Delta x is 1/2. So x sub 0 is 0. And we need to go all the way to x sub 4 because we had said that n equals 4. All right, so 0, a is always 0. In this case, we're on interval number 1. So 1 times 1/2. X sub 2. X sub 3. And x sub 4. So all we've said is that delta x, that we're breaking this up into even intervals of 1/2. And if we're going from 0 to 2, if these are broken up on even intervals of 1/2 starting at 0, because our lower bound is 0, 0, and then 1/2, 1, and then 1.5, and then 2. Okay, so that's x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4 here. All right, so now we have enough information to set up our formula. So we'll start off with a trapezoidal, and make sure you pull up your trapezoidal rule there. So from 0 to 2 of x squared dx, that's going to be equal to b minus a, so 2 minus 0, over 2 times n, so 2 times 4, using the trapezoidal rule, times fx sub 0. So f of x is our function, x squared. Okay, so if our function is x squared, so we have let's go ahead and set it up. X sub 0 is 0, so f of 0 plus 2 times f of 1/2 plus 2 times f of 1 plus 2 times f of 2 plus, I'm sorry, plus 3/2 here, plus f of 2. Okay, so we have 2 over 8, which is 1/4. F of 0, the function is x squared, so 0 squared, plus 2 times 1/2 squared, plus 2 times 1 squared, plus 2 times 3/2 squared, plus 2 squared. Right? So 1/4, and then 0, plus 2 times 1/4, plus 2 times 1, plus 2 times 9/4, plus 4. And then if you calculate that and then multiply times 1/4, you should come out with approximately 2.75 as our integration value. Okay, So that's just using the trapezoidal rule, and all we're doing is plugging into the formula. We have to identify delta x, x of 1, x of 0, 1, 2, 3, and 4 in this case, and then plug it into the formula. Now the Simpsons rule, and again, go back to your Simpsons rule, it says b minus a over 3n times f of x of 0 plus 4 times f of x of 1, and going back and forth there. 2, 4, 2, 4, 2, 4, 2. All right, so the Simpsons rule of x squared dx from 0 to 2, where n equals 4, b minus a over 3n, and then times f of 0 plus 4 times f 4 times f of 1, and then 2 times f of 2, and so on. 2 times, let's see here, so 4 times f of x of 1, which is 1/2, 2 times x of 2, which is 1, 4 times f of 3/2, and then plus f of 2. Okay, so again, it's nothing more than plugging into the formula and then performing those calculations. All right, so we end up with 1/6, and then plug in. So again, the function is x squared, so you have 0 squared, and then 1/2 squared, and so on. So we have 0 plus 4 times 1/4 plus 2 times 1 plus 4 times 9/4 plus 4. And then if you go through and perform those calculations on the inside, get that sum and multiply it times 1/6, you get approximately 2.6667. So make sure you round according to your instructions. And that's using the Simpsons rule, which is usually a little bit closer. And we can only use the Simpsons rule if the n, the number of intervals, is even. Okay, so it's usually a little bit better of approximation. All right, guys, so if you did this analytically like we've done our integration before, in which this one can be integrated, so just to make a comparison here, remember to integrate this, we would add 1 to the exponent and then divide by the new exponent, so x to the third divided by 3 from 0 to 2, and then we would substitute in, so we have 2/3 divided by 3 minus 0/3 divided by 3, and that will give you approximately 2.6667. So like I said, it's the Simpsons rule formula is a little bit closer of an approximation if you can use it, but you can only use it if the number of intervals is an even number. All right, so let's look at one more of these problems because they're all the same. Basically, you just have to go through the process. Okay, and you may want to pause the video and try the problem yourself. Try to find the trapezoidal rule, the approximation using the trapezoidal rule and the Simpsons rule. Okay. All right, so first step, we need to find delta x. So step 1, delta x, b minus a over 2n, where a in this case is equal to 2, the lower bound, and b is equal to 3. So 3 minus 2 over, not 2n, over n. So 3 minus 2 over 4. So that gives us 1/4. So these intervals are broken up into on even intervals of 1/4. Starting, and it should start at the lower bound of 2. But if you need to calculate it, then you would use a sub I equals a plus I delta x, or x sub I, sorry. x sub I equals a plus I times delta x. So x sub 0, a in this case is 2, equals 2, x sub 1 so 2 plus 1/4, 2 1/4 or 9/4. So we have 2, and then we have 1 1/4, which is 9/4. Now if we add a fourth to that, we should end up with what, 1 1/2? Oh, I'm sorry, 2, and then 2 plus this 2 1/4, 9/4, and then add a fourth to that, we would end up with 2 1/2, which would give us 5/2. 10/4 or 5/2. We add a fourth to that, that will give us 11/4. And if we add a fourth to that, that will give us 12/4 or 3. So we have 2, 9/4, 5/2, 11/4, and 3. So we started with 2 and ended up with 3. And we had a fourth, 4 intervals there. Alrighty, so the trapezoidal rule here says that b minus a over 2n, so 3 minus 2 over 2 times 4 times f of 2, f of x sub 0, so f of 2 plus 2 times f of 9/4 plus 2 times f of 5/2 plus 2 times f of 11/4 plus 3. Okay? Now in this case the function is 2 over x squared, so now we're going to plug into that function. So we have 1/8, 1 over 8. So 2 over 2 squared gives us 2 over 4. 2 over 9/4 squared gives us 2 over 81 over 4. And then 2 over 5/2 squared gives us 2 over 25/4. So I'm just plugging this in to our function. And then 2 over 11/4 squared, so that's 121 over 16. And then plus 2 over 3 squared. All right, and then you want to simplify that. So you would flip and multiply. So when you have 2 over 4 over 81, all times 2 should end up with 64 over 81. And again, see, let's go up here and let me show you what we did for this one. First of all, you have the 2 on the outside, and then you multiply by the reciprocal, so that's 4 over 81. And this should have been 16. Sorry about that. I knew I had to make one mistake in the video, right? So 2 times 2 is 4 times 16 is 64. So that gives us 64 over 81. So that's where that comes from. All right. So the same thing on the second part, 2 times 4 over 25. And then 2 times 16 over 121. And then 2 over 9. And then you can use your calculator from there, and you should get approximately, 0.3352. Okay. All right, so n is equal to 4, so that's an even interval, so we can also use find this approximation by using the Simpsons rule. And I'm going to use the Simpsons rule here below. Up here I use the trapezoidal rule. So now let's use the Simpsons rule. All right, so the Simpsons rule, b minus a over 3n. And then f of 2 plus 4 f of 9/4 plus 2 times f of 5/2 plus 4 times f of 11/4 plus f of 3. Using some of the calculations above, I know f of 2, that breaks down, that gives me 1/2. I know that on the second one I had 2 times 2 over 81 over 16. So this is 4 times 2 times 16 over 81. So that's just going to double this, make that 128 over 81. And then 2, I've already calculated that one right here. So it's 16 over 25. And then on this last one I had 2 times, so here I have 4, so I'm just going to double this again. So I ended up with 64 over 121. So if I double that, that makes that 128 over 121. And then the last term is the same. And then again, let's then you go through those calculations, and once you calculate that, you get approximately 0.3334. Okay. All right, guys, that's the numerical integration. That's the trapezoidal rule. That's the Simpsons rule. You follow those formulas, plug in your values, make sure you identify delta x, and then you find your x of 0 and whatever else you need to find, x of 1, x of 2, x of 3, x of 4, according to the number of intervals that you have. So if I have n equals 6, then this will go down to x sub 6. So according to the number of intervals that you have, you find those x sub 0, 1, 2, 3, 4, and so on. So that's it. Calculations, a lot of algebra, and that's about it. Well, I hope you found this video to be helpful, and I will definitely see you on the next one. Thank you, my friend.